So my project was Android Runtime exec analysis. So Android right now is the world's biggest mobile OS with over 100 million users in just the US alone, and they're currently expanding to other devices like tablets and Chromebooks. So since they're so big, they become a target, but since the OS is pretty sound, normally people just try and attack permissions, so they ask for permissions that they don't need or they just do malicious stuff with, and then since people aren't paying attention, they just give it to them, or they want to use the app, so they just give it to them. But like, why do that when you could just run native code anyways and then just never have to ask for the permission? And so what I wanted to do is I wanted to look at all the uses of runtime.exec in the Android open source project. And I looked at 5 different major versions. And to do this, I used grep, and I found all uses of .exec in the code bases. And then I fed those into a program I wrote called Runtime Scanner. And then what Runtime Scanner would return is it would return all the function inputs along with their types, and then whether they were hard-coded, and then based on whether the inputs were hard-coded, we could determine whether each .exec call was hard-coded. And so what I found is that over 560 uses, there were 90 where you could change the inputs, like just to anything, and then 150 where you could influence it through the use of the class because it took some inputs from there. But the problem with this is that a lot of .exec is used in the just unit tests. So I tried to remove everything with unit tests, and that still left 160 uses across the 5 versions. And then there were 40 where you could change the input, and 60 where you could influence it through the class. So what I found is that the Android OS is probably pretty susceptible to this type of attack, and that it's definitely something to look out for, and they should probably sanitize all of these uses because none of them are actually sanitized.